Hello, we've started. Welcome to, I think it's the fourth video, it might be the third video, where we're using a mesh to build a version of Minecraft. Right, last time we got the infinite terrain working with Perlin noise, and what we need to add in this video is mining, such as, well, you know what mining is, but there you go. So I've got like a highlighter, as it were, to highlight the block that we want to dig away, and then when you press the left mouse key, we mine a block. There we go. So that's what we're going to build, and then our collisions are working. So remember, our collisions just work via the Terrain Dictionary, which is a very efficient way of just storing. There's just something weird going on over here. What on earth is going on there? It's really slowing down the computer. There's a weird block in the middle there. I don't know what that is there for. I must have been doing something else. Anyway, this is my prepared code. And yeah, that really slows down the frame rate when I go near this random block. I'm not sure what that is. Anyway, what we're going to do, the way we're going to do this is, I was talking about the Terrain Dictionary. It stores, as we make a block, the coordinates in 3D space, x, y, and z, of that block, so that we can say, if the subject or our player is in that position, raise the player to that height of block. And so when we do some mining, we need to change the locations, or like delete or remove from the dictionary that there is a block there, so that we don't still stand on it. And what we need to do the mining is we're just going to change the mesh. And specifically, we're going to change the little corners that make up each block's model. And those corners are called vertices. So what we need to do to get hold of the vertices is we need to know what index number each vertex is at. And they're stored on the subset, and subsets make up the whole terrain. So the meshes or the models of each subset make up the whole terrain. So on those subsets, there is stored a list of vertices which make up the model, the terrain that it holds. So all we have to do to get hold of the right vertices, the correct vertices, that's the name of the game here, to mine. So if I click this block, I don't want a block over there to disappear. I want the correct subset to be affected and the correct vertices, i.e. just those vertices that make up one block at that location. And we found out in previous videos there are 36 vertices that make up each cube. So all we have to do is iterate over all those vertices and then remove them. So how do we do that? Well, the simple solution is when we build a block, we just need to make a note of the index of the first vertex that is going to be on that list. We don't need to track the indices or the labels for all 36 because they're going to be stored in consecutive order. So let's say the block that I'm highlighting now, let's say it's subset 5, and the first vertex is like number 15. So I just need to store number 15 and then count another 36, and when I click, I can remove just those vertices. So that's how it basically works. Let's go and do the coding. So, a Merry Christmas, by the way, if I haven't said so already. Sorry for wearing black. I know that's against Christmas rules. Right, so I've got my prepared code here. We're going to add one module. Let's just have a look. Where are my modules? Here we go. So far we've got a main module, which is where we run our code from. We've got the mesh terrain module, which looks after creating the terrain. So that would be very important because that's where we build blocks and things like that. So when we've done some mining, we'll also want to spawn a few blocks underneath, so it looks like we've got infinite layers as well. And then we've got the swirl engine, which we did last video, which enables us to just walk around the terrain and infinitely generate using Perlin noise. So our Perlin module, Perlin noise, control the heights of a terrain at different locations. So we need to add a mining system. That's what we're going to do, a mining system. So let's create that module first of all. So back in your favorite IDE, wherever you're writing your code, we need a new file. Oh yeah, I select my language, Python, there we go. And then I'm going to save this as mining system. So I'm inside my folder. Mining underscore system. There we go. Lovely. Right. Let's have a look at my, and I'll move that over here out of the way of my prepare code. No, it's not moving. Now it's moving. There we go. Right. What's the first thing I need to do? Let's have a look at our mesh terrain. Well, first thing we need to import that mining system. Oh, I know the kind of first job we need to do. The Vertices Dictionary. So we need to make a dictionary, and what that's going to do, yeah, in generate block, we're going to record, there it is, record which subset and index of the first vertex on our Vertices Dictionary for mining. So that code there. So let's go and do that. So in our mesh terrain, firstly, let's just, from our mining system, import everything. There's nothing in our mining system yet, it's just blank, but we'll import everything in preparation. And then, yes, here's our terrain dictionary. So just underneath there, we're going to, oh, let me just pause and do something. I'm going to do something very similar here. Let's call it Vertex, not Vertices Dictionary, let's just call it Vertex Dictionary. Okay. For mining. It's useful in your comments if you actually say the purpose of why you've got something there. So yes, we want this VD equals, and then curly brackets to say that that's a dictionary. And that means when we generate a block, after we've recorded our terrain in the dictionary, we can then say record subset index. So we need to know which subset we're talking about, and first vertex of this block. There we go. So this dot VD, and now we need to get hold of a very similar, or in fact identical location. There we go. So we build our dictionary key. So it's going to look like an X and then a number, and it's going to be floored, and it has to be a string to concatenate it into a string key. For X, Y, and then the number, and then Z, and then the whole number there as well. And that's going to equal, and then I think I store two things here. I think I store the subset index and then the first vertex. Let's just have a look at my my prepare code. Equals vob. So I just created like a vertex object. I just created a little variable there, and there we go. I've stored the current subset, and then the length of, I'm taking the length of our current subset's model and how many vertices we've got so far. So that's, we've just added to this model these vertices. So we've just added another 36. So we want to go back to the first vertex in that list, which will be minus 37, because it indexes like this start at 0. Okay, so let's take that. And we're going to have to get subset from somewhere, I'll talk about what's going on there in a moment. Right, so back to mesh terrain. So that's going to equal vob. I like that. That's just a temporary variable here. So vob is going to equal a tuple. So if I put in brackets here, that's just going to be a data structure in Python that stores, more than one item. So first we're going to take the subset index, which doesn't exist yet, and then we want the length of this model's vertices. So it's the length of that list, and then we're going to minus 37 to get just the first index of the first vertex there. Right, so subset, what's that about? Well, when we come to do some mining, we're not going to, or when we generate some walls of the terrain underneath of the place where we've mined, because if we just mine, we're going to leave a gap in the mesh, and we can see through, and we'll see that it's just like one layer of blocks. So we want to spawn some blocks, so we're going to generate some more blocks. Now, we want to attach those blocks to the subset that describes that area of the terrain, not just the current subset, because the current subset will be off somewhere else, generating and swirling around the terrain there. So we want to talk about a specific subset. So when we generate a block, we're going to pass in the subset number that we want. And so this is going to be subset in here. Now, what if we're using generate block in just a normal way, the previous way, to generate the terrain? Then, for example, or specifically, when we're using the generate terrain function, and there we go, we're using generate block, and we're not passing in a subset, and we just want the current subset. So that I don't have to change any of the code down there, we'll use a little Python trickery here. What we'll say is at the start of generate block, we'll say subset has a default value of -1. And then at the beginning of the function, we can say, well, if subset is -1, then subset will set to this dot current subset. Now you might think, why don't I just put subset equals as a default this current subset? That's because you can't do that up there in the declaration of your function. But we can do it in the body of the function itself. So there we go. So this hasn't changed the code so far. Subset here does mean current subset if we don't pass in any value. Okay, do I need to change that anywhere else? i.e. we're looking for current subset. No, that's all okay. So we only had to change that. Okay, so now, we are storing every block that we're generating in our terrain now. We're recording what subset that block belongs to. And I think we're doing it 4x4, is that right? Yes, our subwidth, so each subset will be 4x4 blocks, or 16 cubes, 16 blocks. And so for each of those blocks, we're recording which subset number we're currently on. So the 15th block will be, sorry, I can't count, I went backwards. The 17th block will be the first block on the new subset. So that number will change there. And then after another 16, will be the next subset. And then we're going to record on that particular subset what vertex number. So now we can do some mining, potentially. Right. What we also want to do, is highlight our blocks. So let's just run things, make sure we haven't destroyed anything so far. So I need my main module, and we run from there. I think I saved everything. Okay. And I can walk around nice and smooth, and we're okay. Okay, so now what we want to do is, highlight blocks that we're looking at. So how are we going to do? So essentially what we want to do is create like a temporary entity, and we call this the build tool entity, because we can build with it and we can mine with it, and that's what I called it in my previous playlist. So for those of you who have changed onto this new playlist, it'll be familiar. So we're going to just create a block, just a simple cube, and we won't give it a collide or anything, and we'll basically say position yourself from the player's position, and then using the camera, which is this kind of secret behind the scenes entity that moves around with your mouse, and it points wherever you're kind of like looking. And so we'll use that direction, that vector, that's a direction with magnitude. We'll use that direction in 3D space from the player's position, and then go forward like 5 or 10 units, and then say, is there a block on the dictionary in that position? And if there isn't, stay invisible. And then we'll say, and then we'll keep coming back down, all the way down to the player's position. So if there's a block right in front of us in that position, then we'll make the BTE, the build tool entity, that cube, we'll make it kind of see-through and yellow and just sit there. And it'll look like we're highlighting the block. Okay, so that's what we'll do. And actually, when I say we're going to check 10 blocks away, we'll then check 9, 8, 7, 6, and get as close as we can. And so we're always highlighting the closest block to us, but we will check from far away to begin with. Right, let's make that happen. So this will be in our mining system. We can actually do something in here. So how have I done this? Let's have a look. So firstly, we need to build our entity, and its color is going to be loads of red, loads of green. That makes yellow. So you can just put 1 in here to have like maximum value. You don't have to put 255. Ursina will work out what you meant. And then the fourth argument in here, if you're using color.rgba, will be the alpha channel, hence the A, and 0.4 is just less than half opacity. And so it's just going to be a cube, and then its scale is going to be 1.001, and that's so that it's not exactly the same size as cubes, but slightly bigger, so we don't get any like faces being in exactly the same position and kind of fighting, and they'll look horrible if they do that. Right, let's go and sort that out. So we need a BTE equals a new entity, and then we want the model to be a cube, and then color will equal color.rgba, and then we want red, loads of green, no blue, so that'll make yellow, and then 0.4. Obviously, you can change these colors to something that you would prefer. Right, now, this module won't run because it doesn't know what an entity is. Although we're using Ursina in the other modules, we need to import Ursina again here. So from Ursina import, we just need entity at the moment. And, oh yeah, we need color as well. So some of these keywords or objects don't exist in native Python. You need to import them from a module, namely the Ursina module. Okay, whoops. Now what we've literally forgotten what to do. Good job. Oh yeah, the scale. The scale. So where am I? Mining system. BTE scale equals 1.001. There we go. Did I kind of like multiply it in my prepared code? That's weird. I've multiplied it there. You shouldn't have to multiply it. Anyway, we'll see. If it goes wrong, that's a thing that we've learned. Right. Highlight. Here's our highlight function. So we need to take a position, a camera. So the position is going to be the subject or the player's position. The camera is going to be the camera object that I was talking about. And here you can see we're using it there. So cam.forward, it will be that vector pointing in the direction that the player's facing. Lovely. And then TD will be our terrain dictionary. So we can then check whether we're looking at a block that's on that terrain dictionary. And we can use a terrain dictionary here because it's really fast. We don't have to do much calculation with it. Okay. And then essentially, yeah, we're just making that terrain block visible or invisible. Oh, I've put a collider on it. That's interesting. I shouldn't have to put a collider on it. Oh, oh, that's where the white box is coming from. I think I was doing some testing of something. This is just in my prepared code. I'll just take that off. There we go. Oh, I know what I was doing. Right, that's for a future thing. Okay, so. Right, let's get this highlighter function working. Right, you're probably also thinking, what calls this highlight function? It'll probably be in an update loop because it wants to be happening all the time. So the update loop actually happens in our main module. So I'll have to go back there. Right, so def highlight. And so what do we need? We need a position of the player. We need a camera object so we can get our direction in which we're looking, and then the terrain dictionary. Lovely. And then what we want to do is go and look at my code. Yeah, we want a for loop for I in range, and I'm going to go look 15 objects ahead of me, and then that wants to go to 1, and then we're going to go in and decrement by 1, so -1. I don't remember doing that in my code, 1 to 15. Does Python just know to go backwards? That's weird. Maybe this is a bug that makes things work. Anyway, I'll stay with my code because it works, and then, yeah, right. So, WP means like what position are we currently at? If we take our current position, the camera direction, times I that we're using our iterator in our loop here, and then we're going to floor those values so it fits exactly where our terrain can be in terms of an integer. So x can only be like 1, 2, 3, 4, 5, or -7. So that's why we're using the floor there. Oh yes, and we're just lifting. It looks like lifting the y position up by 3 to match our height, approximately, and then the BTE object itself, or entity itself, that cube, that leaves a highlight color over that position. It then uses these values, but we just raise it by half because the model that I'm using for the terrain, it's actually off by half. So native models like this cube built into Ursina are off by half, so we just have to address that. Right. Keep clicking on the wrong module. So WP equals position, so that's a vector 3 object, an x, y, and z. So I can add that to the camera's forward, which is also a vector, so it has an x, y, and z. And we're going to multiply that by I. So we're going to go check all of those blocks along that trajectory, along that vector. And then we can say a temporary x will equal w. Oh yeah, we're going to floor that, aren't we? Floored wp.x. Y will equal floor wp.y plus 3, just to raise it to eye level. And then z equals floored wp.z. And then our BTE, our build tool entity, our highlighting cube, we can inherit those terms. BTE.y equals y plus 0.5, and then BTE z equals z. Now we're going to ask a question. We're going to ask, oh, where am I? Mining system, yeah, I am in the right place, sorry. We're then going to say, if we can get some terrain in that position, So if there's a T, if the train is marked as T there, then BT is going to be visible. So I'm just going to copy that code to help us out, speed things along a bit. Mining system, yep. There we go. So if our train dictionary, which we passed into this function up there, and we're going to take the X from up here, the Y, and the Z. Notice that the Y isn't at something 0.5. That's just a BTE's model's position. The actual position we're looking for will be a whole number. So the whole number here. So it's not Y.5 here. It's going to be the whole number. So if that does equal T, then we can say BTE visible equals true. Lovely. Oh, do we go from 1 to 15? No, wait a minute. What did I do? Let's have a look at this. Because what I'd want to do is check like the first one and then break. Is that what I was doing? Oh yeah, look. How weird. You must have been thinking, what am I talking about? It doesn't go from 15 to 1. God, my perception just flipped that around consciously. That's really strange, yeah. So we go from 1 to 15. So we check the nearest one. If we haven't gone 1 there, we keep going. But if we run 15 ahead, then stop checking them. Okay. Sorry to confuse you back there, but now we're crystal clear. So we use the break keyword. Once we've found a cube, and we can turn on the highlighter, then we don't need to check the rest of that trajectory. We've got the nearest cube to us, which is what we want. Do I just use else now? How do I then make it invisible? Do I just say, if there isn't one there, yeah, it's false. So that will keep running. If we don't hit that break, it will run all the way along the 15, and then the last one will make it visible. We'll make it visible false. Which is a little inefficient, but not too bad. Else BTE dot visible equals false. And now that I've put that equals like that, I can't sleep. Let's do it like that. Okay, lovely. I don't think floor exists up here, so I think I can take floor from Ursina. It kind of sits on top of the Panda 3D module, doesn't it? I think that's where it gets the floor from. And it'll get it from some maths module or something. There we go. Okay, so just because we've written our function, our highlighter won't work yet because this function's not being called. So we have to call it every frame. So we want to go back into the main module. And here's our update loop. So at the moment, this is calling the terrain to be built. So what we could also do is every 2 frames, we could also let's add a little comment. We can also we'll just say highlight terrain block for mining / building. And what we're going to do is actually call a function on the mesh terrain class, because everything to do with the terrain should be handled in this module, not in the main module, to keep the main module as lightweight as possible. We're under 100 line, which is nice. So it's easy to find bugs and things. And mesh terrain, probably a little bit bigger. Yeah, it's heading towards 100. So we're trying not to add too much to this, but we do have to add a few things. So in mesh terrain, all we have to do is create ourselves. I'll just create it here. So we're inside the body of that class. And you can kind of line it up with the other functions. So def update, and what we need to receive is, yeah, the subject's position the camera object, and then we don't need the terrain dictionary because the terrain dictionary is already part of this function, of this object, this class. But then what we're going to do is call the mining systems highlight function and pass those in. So we can write highlight position, camera, and then this dot td. There we go. You can pass those in. Is that what I've done in my prepared code? Let's have a look. That's the mining system. I need to look at the mesh terrain. I just remembered we haven't done everything we need to do in generate block, but I'll look at that later. Generate the terrain. There we go, the update function. So yes. Oh, I forgot the this keyword, didn't I? Or self, if you're writing better Python than I am, because it is a member function of that class. Yeah, position to, and then dd. Brilliant, that's all we needed to do. So mining system is not where I'm supposed to be. Mesh terrain is, yep, I forgot the this keyword. So you'll notice all the functions or member functions, or methods, I should say, methods of this class will begin with the this keyword, which is what most programming languages use. As I've said in previous videos, in Python you're supposed to say self. So you'll see self, 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 self in other things. So let's have a look. Yep, this. You get the idea. Okay, which is what I forgot. Right. So that's done. Let's just highlight looked at block, smiley face. I don't think I've passed these in yet from the main module. So in the main module, yeah, here we are, back in the main module. So we're in the actual update loop. So this is the one, or function, that does get updated. So then we can say get hold of our terrain object, which is the name of the mesh terrain that we're using. We can then call update, and then we'll pass in subject's position, so our player's object, and then dot position will be the vector 3, our x, y, and z position, and then we want the camera, which I think I just passed in the whole camera, and that's it, isn't it? And then the rest is taken care of by mesh terrain. It just passes those two through, passes them on, and then this TD is passed on. Right, now we can run from our main module and just see if we're highlighting any blocks. Oh my god, I really didn't expect this to work already. Oh, that's quite exciting. So that's working. Brilliant. And if I click, nothing happens because that's the next thing to do. So we've already done part of the work for getting mining ready. We've marked which vertex begins each cube here. Right, how long have we been recording? Just over half an hour. Let's see if we can do it. Why do I say 45 minutes? That's not going to work out. So next thing we want to do is, clickety click. So in the main function, let me go and have a look at my prepared code. Presumably in the, similar thing. Just like from the mains update function, we're asking the terrain object to go and run its update function from our mains input function. So that listens out for any input, like the mouse and the keyboard, things like that. And it takes a key argument, and that's whatever key you've pressed, including the mouse buttons. So we don't want to look at all of that inside the main module. Again, we just want to pass that job to the terrain class to look after. So let's just go and write that. And then we don't have to do anything else to the main module, I don't think. So we haven't got our input function, so let's write that. Did you see that? My brain switched def to fed. It keeps going backwards. So input, that takes the key argument, and then we can just say, well, terrain, could you go and run your input function? Here's the key, done. Okay. So go not to our mining system, but our mesh terrain. And why not, just underneath def input, def update, we'll say def input this keyword, and then take the key and then pass that through. No, we're not going to pass it through. We're going to ask the question: if key equals left mouse up, then we must have pressed once. So it's not holding the key down, but releasing it. That's the inbuilt Ursina like default phrase that we're going to use. If that's been pressed, then we want to go and run the mining function. So I think we can do the mining function inside this module where we've written our highlight code. And what do I pass through? So let's have a look at my mining system. So I've called it plant idea. I should have just called that mine. So we'll call this mine, and then I'm going to pass through both dictionaries. So we need the terrain dictionary and the vertex dictionary, and then all of the subsets so that we can do stuff to the subsets. So that's not massively efficient, but we'll refactor that later. So yes, where am I? Where am I? I want to go into mesh terrain. So I'm going to say mine. There we go. And we're going to pass in this dot terrain dictionary, this dot vertex dictionary, and this dot this dot subsets. Okay, we're going to pass all of those objects to the mine function. The mine function, which we're going to write in here. So let's write it underneath highlight. Have I got lined up? No. Oh yeah. So we're not in a class in here. We're not in a class. This is just a place where we can do stuff. So we're not bulking out the mesh terrain with all our mining stuff. We're going to do the mining stuff separately, as much as we can. So define mine. So we don't need a this keyword because it's not part of the class itself. We're going to write what we're going to write. We need TD, and the vertex dictionary, and subsets. There we go. And we've got an S on the end to remind us this is a convention used in programming, because this is not just an ordinary variable. It's a list or an array. It's got lots of things on, so it involves plural things. So we put the plural S there. So what do we want to do? Essentially, we want to get hold of our subsets first relevant vertex that BTE has got hold of, and then for each of those 36 vertices, we're just going to shoot them up in the air. So it's kind of tearing them away. I haven't found a good way to delete them, which would be the best thing to do. Anyway, this way works. So if you have any ideas how to improve this, let me know in the comments. But also, what if the BTE is visible? Invisible. That means we're not actually highlighting a block at the moment. So if we try and mine something, and the BTE is invisible, so it's not highlighted something, this will go wrong. So we'll just say, if the BTE visible, haven't written if BTE, can I just write if not BTE visible, then return. In other words, don't run this function if the BTE is not visible. Is that how I did it in my prepared one? That'd be really interesting. Yeah, if not BTE visible, return. Lovely. Let's just have a look at my code and maybe do some copying here. So which vertex? So we need to get hold of the vertex. And we can use, the BTE's current position to build a dictionary key. So that's the key, the location of the highlighted block, terrain block. And then what the Vertex Dictionary records is which subset it's on and which vertex. So that gives us everything that we need. So shall I attempt to write this? Okay, let's attempt to write this. So which vertex will equal, we're going to get hold of the Vertex Dictionary and then .get, and now we need to build our key. So I'm going to write this out so I'm not cheating. Plus, we need to floor this number, and it's going to be, well, it should be floored already. BTE, oh no, BTE is actually at 0.5 in terms of the Y, but I should only have to floor the Y. So let's just try and do that. I'll try and improve on my code. So I should just be able to say BTE.x, because, it's already floored, except for Y. Yeah, I believe that. I believe it. So then we're going to say Y plus, but it does need to be a string. So we're going to wrap that in strings. There we go. Plus string, and then we do need to floor the Y one. BTE Y plus our final one. We're almost there, very confident. BTE Z, or Z for our American friends. And that's it, closing brackets. So which vertex we've got hold of. And now remember, it's not just a vertex, we're actually receiving a tuple. When we create each block in the mesh terrain class, when we create or generate a block, in the Vertex Dictionary we're storing a subset number and the vertex number. Okay, so we've got that. And we know that we will have got one because we can only run this if BTE is visible and therefore it is highlighting a block that's on the terrain. So that's fail-safe. So now we're going to run a loop. So we want to just iterate over all 36 of the vertices on that subset, starting at that position. So for I in range wants to be WV. So if we're dealing with a tuple, it's just like a list or an array. It'll have two positions on it. So it's like two buckets. This one's labelled 0. Well, from your perspective, this one's labelled 0. This one, or the next one, the second one, is labelled 1. So I recorded the subsets on the first one. So that's going to be at index 0. And we want to go to 35. WV 0 plus 36. There we go. Or is it 35? Oh no, because the range doesn't include the second number. So that should be 36. Let's go and have a look at my prepared code. No, it's 37. That's hilarious. And also, I'm using the second one. Oh! Well done if you saw my error. I don't need the subset number, I need the vertex number here, obviously. So that's in the second pocket. And then, we go to 37, because the last one we want to hit is the 36th one. I don't think anyone believes that I know what I'm talking about. Okay, although my past self did. Present self doesn't know what's going on, really. Right, and so all we're doing there, we've just got one line. One line there. We're saying subsets, now we get hold of the first thing on our tuple, so at index 0. The model, that the vertices list, the current number that we're looping around, and we want to get hold of the Y position of that vertex and we're going to add 999 to it, so it raises it up in the air, so it tears it off of the terrain. Okay. So, so what do I do? Oh my god. Subsets, there we go. So we've passed in subsets. So that's all the subsets that have made up our terrain. Subsets, and we want to use subsets. So this is which vertex, and now we want 0 on there. There we go. That's our subset number. Model, vertices. Now we want the current vertex that we're looking at. So that's going to be I. And now a vertex is a vector 3 object. So it's got an x, y, and a z position. It's just a point in space that makes up the corners of our model. So we've got hold of the vertex, but it's got 3 components on. So we need another square bracket here. And so the first component of that is the x position, or the 0th index. The second one is the y position, which is what we want. So that's going to be the first index. And the third one is going to be index 2. So we want just that middle one, in other words. So that's a y position. And then we're going to add on 999. We've gone over 45 minutes, but there we go. Right, so after we've done that, so what have we done so far? We've just grabbed hold of the right vertex number and the subset number. We've got hold of the right subset, got its model, gone over the 36 vertices, and we've changed it. Now, that won't change it on the screen because we need to update this subset's model. So we're not going to do that every time we change a vertex. We might as well do that after they've all been changed. So we're just doing one call to that function to speed it up. So again, we get hold of this model. I can just copy this little bit of code, hopefully which is correct. And then we just call the generate function. There we go. So that will update the model. Okay, so after we've done that, we've changed some information, or we need to change the information. We've changed the terrain visually, but if we walk over that mined spot, we won't fall down. Let's just see if things are working at the moment, which will be fun. So go to main, run this. Good. Nothing's crashing so far. And then if I press a key, now it crashed. What have we done wrong? None type object for I in range WV1 to WV plus 35. None type object is not subscriptable. So I'm trying to access something that doesn't actually exist. Although I got the right input phrase for the mouse, that was good. Let's just have a look at the prepared code. Oh, it's +1, isn't it? Because I'm storing, I'm storing it slightly wrong. I could store it -1, and then this would be 36. Right, okay. Okay. Well done if you spotted that as well. There we go. So in other words, we're trying to get hold of a vertex that might not exist. Well, didn't exist in that case. Let's try again, main. So at least our mouse was doing something, our mouse button. And our highlighter was still working, so we hadn't damaged that. So try and delete this guy. Oh no, still not. That wasn't the problem. WV +1. Let's have a look at my prepared code. So it could be the BTEY not being flawed. I'm sure it can't be that. Let's have a look. Mining system. I could be building this slightly wrong. VD get. All strings. Yeah. V in range WV1, WV1 plus 1, and it is WVO, isn't it, in the subsets, is that right? WV0, yeah, model vertices I. Well, I'm using V here, but that doesn't make a difference, of course. Well, I don't think it's the fact that I've not floored these. Let's just try that. If that doesn't work, it might be to do with the fact that we're removing those vertices and the BTE is trying to highlight a block there. No, I don't think that's it. Is it just a simple mistake that I've made here? I can't see anything. I think it's fine. Anyway, I can always pause it and then look for it. Let's just have a look. If it's this flooring business. Oh, it could be, couldn't it? Because if it's taking the BTE position, yeah, of course it's that. Well done if you also anticipated this problem. It's because, yeah, if I'm just taking the raw BTE, X and Z, they're not stored as integers. They are stored, of course, as floating points. So at the moment, it's quite a nice effect is, although we've deleted these things visually, there aren't real gaps here because our character and our BTE entity, our build tool cube that's doing the highlighting, is reacting to the terrain dictionary, which doesn't know that we've actually mined anything. Can actually mine something again. Oh yeah, so if I keep mining, it'll keep lifting those invisible points. Right, but quite exciting. We've got mining almost working. So now what we want to do, yes, so we're back inside our mining system in the mine function. So after we've regenerated our model, then we want to get hold of, let's go to my prepare code. Actually, I'm going to copy and paste this. G for gap in the terrain and wipe the VD entry. So, yeah, we want to record first of all, on our terrain dictionary, that there's not terrain there, there's a gap. So if we get a G, and that's because, this is for something else. This is for later on when we're going to spawn some terrain walls so that we can give the illusion of digging down and down and down. We need to know where we've actually mined. We don't want to accidentally spawn a block where we're looking through. So we need to record where our gaps are, in other words. So that means, actually, while I remember, if I go back to the mesh terrain module, is it in mesh terrain? No, it's going to be in our main module for walking around. Yeah, we're going to say if the terrain at that position equals a T, then oh no, that's fine. That's fine. Because if it's a G, then we want to fall down as well. So that's fine. Just make sure yours says equals T. I think that's fine. Okay, forget that I just said all that. That's fine. We do need to do some more stuff though. Talking of the mesh terrain, in generate block, we kind of need to record like there's a gap on top of all of the surface. As you'll see when we start spawning some blocks, you'll see why. Anyway, let's go back to our mining system. And then yes, So I'm back inside the mine function, and then we need to kind of say there isn't a subset index or a vertex on the Vertex Dictionary right there. So we just enter none with a capital N. Done. So then we'll be able to fall through those gaps. Let me just look at my prepared code because I'm then returning something. I can't remember why. I'm returning the BTE position plus... Oh, I know what I'm doing here. This is for spawning the walls anyway, which is the last thing that we need to do. I'm just going to run it again just to see if our terrain dictionary is responding to doing some mining. So that's still working. Can I fall through there? Yes! So mining is officially working. Very good. Good. Just a word. Oh, we're in the main dictionary, main module, not dictionary. I'm just thinking we could try to generate terrain every update and change this to maybe a 4, and then place this maybe earlier on in the update loop. So that would generate terrain faster, and we'd only update. We'd only see the or we only need to see the highlighter maybe, let's try every 8 frames or something. Because it's kind of doing a lot of work, it might speed up our game. Let's just see. It'll certainly make the terrain generate a lot quicker. Like that's whizzing through. I'm still getting a very good frame rate. It's a little low. I think it's mainly because I'm recording. But that feels nice and smooth. And it's highlighting in a reasonable way. There we go. So I can do loads of mining. If I click too fast, then I create a bug. Anyway, I'll have to address that bug later on. Right, so that's working fine. I might just then drop that number to 4. Just in case that was to do with the bug there. Anyway, right. So what we want to do is after we've made a hole, ruined our terrain, we want to generate or spawn a cube underneath that position, and then some walls. But we need to know like the position underneath that, and then we can make use of our generate block function. We don't need to write a new function to do all of this to generate a block. We just need to pass to generate block where to generate. So it needs to know what subset and what location in 3D space. So what I've done, when we press a key and we go and run mine, we could return what subset and what location, and then pass that to generate block. I think that's what I've done with the mining system. So there I just return. Let's just see. So in the prepared mesh terrain, if I find my input function, there we are. So I'm storing something like epicenter, I think that stands for. So that will store the position where we want to spawn a block. This generate the walls. Oh yes, and if I'm saying if we've returned none, i.e. we're not doing mining, then generate walls doesn't run. And what are we returning? We're returning the subset number, presumably, and a vector 3, is that right? Oh yeah, that's a subset number, so it's the position that we want to spawn, so the center of where we need the walls, and then the second thing we're passing through in this tuple is the subset number. Okay, so we know which subset to add our walls to. Right, let's try and recreate this in our code. So we want to go to the mining system, I guess, first. So we're in the mine function, and there we want to return a tuple. So we need parentheses, and we want the bte dot position plus how do I write 0. Do I just create a new vector 3 and then just say don't change the x, do change the y 0.5 and then 0 again there. Is that what I did? Oh, it's minus. Oh yeah, because we moved it up, so we need to move it down by 0.5 again. What am I talking about? It's up here. So to line up the built-in Ursina model with my terrain model, which I made, they're kind of 0.5 off on the y-axis, as I mentioned before. So because I made that adjustment here, I've raised BTE to 0.5. Down here is where we're going to generate some terrain. So that needs to be adjusted back down to 0.5. So that's why that's happening. And to do that, I take the BTE position and then just add to that, just change the y component of that vector 3 there. Vector 3 might not exist here, so I think it's in Ursina again. Just add vec 3 up to our import. So this is at the top of the mining system. And then, so that's the first thing we're returning, and then we want to return the subset number, so that's WV0, index 0. So that's just a number of which subset to add or spawn the walls to, generate a block on. Okay, so now back into mesh terrain. Yeah, we just need to make this a little more complicated. So we're going to say epi, so that's just going to stand for like the epicenter of where we're mining. Epi equals mine. There we go, which is a bit weird. It's going to equal that function. That just means whatever the mine returns is going to be epi. So it's going to have two things. And then, look at my code, we need to, generate walls. So we need a new function. This is the last little step we need, which is how many lines? Not too many. What's that, about 13 lines? So let's go and do that. So it takes an epicenter and a subset. Where am I? Mining system, mesh terrain. So spawn walls, or do I call it generate walls? Gen walls. There we go. And so it's going to be epi. Epi 0 and epi 1, which correspond to the position that we're spawning things around and the subset number. And then let's just write gen walls under here. And we'll just write a little comment to ourselves, i.e. after mining to create illusion of depth in the terrain. So remember this keyword, and then it's going to take an epicenter, I'll just call that epi, and subset. It's a current subset that we want to affect. Now, if epi equals none, so nothing's being passed there, then return. So, in other words, don't run. Oh, do I have to make this, it's going to be this genWalls because it's a member function. Mine isn't a member function, it's part of this module. So that's why it doesn't have a this keyword on. And the reason why we're not adding this generate walls, which feels like a mining thing, is because we need to get hold of this generate block function, which belongs to the class. So we have to do that in here. Now, what we want to do is just generate a block at the position underneath the epicenter, on top of the epicenter, forward and backward, left and right. So it's 6 blocks. But we don't want to generate a block if there's some terrain already there, or there's a gap there, a G. So where am I? Mesh terrain. So all we're doing is running this little loop. So 0 to 6, so 6 different blocks, and we want to say the new position is the epicenter plus a vector 3, which just takes us 1 above, 1 below, 1 behind, 1 in front, 1 to the side, or 1 to the left and 1 to the right, or back, or this one's backward, this one's forward, this is left, this is right. So it's just changing the Y, the X, and the Z position of the epicenter, and then at that position, we're saying, well, if there's not a gap and there's not a T, so if that terrain dictionary location is none, then we can generate a block, and we tell it what subset. So I'm going to copy all that. There we go. Mining system is the wrong place. We should be in mesh terrain. Copy all of that. So I guess actually I could have put all of that in the mining system, and then it just returns these positions, and then I can just generate block here. I'll maybe refactor that later on. Let's make a note. Refactor this, place in mining system except for call to gen block question mark. Can I do it? Okay, so what we do here, we prepare for the loop. So WP will just stand for what position are we generating a block, and we're creating this list, so square brackets, and then separate each element with a comma, except the last one doesn't need a comma, and that's just moving around this position, up, down, left, right, forward, backward. Okay, so then for in range 0 to 6, my new position equals the epicenter, which I've called epi, so I need to change that, plus each of these 6. So I'm just using the iterator, the iterating object there. So it goes 0, 1, 2, 3, 4, so it uses that one, then that one, that one. So it goes around the position, and then it checks at that position, the terrain dictionary. If there's nothing there, then generate that block. Brilliant. And we pass into generate block the subset number, which is never going to be -1, so it's going to take the subset number and generate block that. Right, so let's run this, because there's one thing we needed to kind of like do. Well, let's not get ahead of ourselves. If there's no errors, no bugs, then there's one last thing to do there. So let's try and let's even this out. Okay. Oh. So it did kind of work, but now we've kind of like grown. We've grown stuff there, and it's not actually changed the terrain. Oh, it has changed it. Has it changed the terrain dictionary? No. So terrain dictionary is not being changed, which is weird. But also we forgot to generate generate the mesh again after we've done that. So let's just have a look at my prepared code. So I return that there. Yeah, so in, where is it? Let's just go straight to the, not the mining system, I need to go to the mesh terrain. Yeah, after we've generated those walls, in generate block, nowhere do we generate or regenerate the mesh of that subset. So we need to do that here. We need to say this dot subsets, and we just need epi 1. I think that's going to be the subset. Model generate. Right, before I test that, let's look at the prepare code. Yeah, it's epi1 model generate, and we do that in the input. Brilliant. Let's just see what that change is. I'm a bit confused about why I wasn't able to stand on those blocks. Oh, it might be because at the moment our collision system isn't very sophisticated, so we just stand on like the lowest block at that location. So let's use a mouse, sorry. There we go. So that instantly changes, and yeah, because we're you can see it's generating those walls all the way outside. If I do all the way around that location, this one we can stand on because there is a gap underneath it where we mined. So it is the lowest block at this position. So that's working correctly, so that's fine. So what we actually want to say is when we generate the terrain, on the surface we need like an invisible layer of gaps because we don't want to generate a mined like wall there. So let's go and do that. Let's see if I can do that without looking at my prepared code. So we go back into mesh terrain, and in, this is running very slowly, in where we generate block, record terrain in dictionary, and we also want to say also record gap above this position to correct for spawning walls after mining. Okay, so it should be exactly the same, but for the Y position. So we just need to raise the Y position by 1. And we don't want to say there's terrain there, we want to say there's a gap or a G. And that means back in, mesh terrain, sorry, we're still in mesh terrain. When we're in, in generating a wall, we're asking, so let's pretend we're above the mine position. We're saying, is that position, is the terrain dictionary there saying there's nothing there? And it isn't. It's now saying there's a gap there, so it can't generate a block. Okay, so we'll save that, run main, run this, and hopefully that will be the final step. We should be able to have the illusion of mining. Let's have a look. There we go. So remove that block, remove that one. Oh, lovely. Oh no. So blocks are bizarrely returning. That was really strange. I don't know why that was happening. It might be, I don't know. And now I can't refer to this block. And then there's something not happening there. Right, so something's not happening with recording the dictionary for spawned blocks. Let's just quickly have a look. Otherwise, I'll finish the video if I can't find it straight away, and then I'll put the solution in the description of the video, so you don't have to wait for me now. Right, let's have a look. Were we even looking? Mining system, not the mining system. In mesh terrain. Might be in generate block. Oh, it might be because we don't want to record a gap if we're just generating a what do you call it, a spawned wall. That's probably it. So let's just have a look at my prepared code. Mark one above as gap to prevent walls and mine site spawning. Yes. So it's a bit more sophisticated. First I build the key, and then I say, if there's no terrain there, then you can mark it as G, because there might be some terrain there already if it's a spawned wall. So let's just copy this little bit of code and replace my bad code. Oh yeah, i.e. the one bit of code that I tried to make without looking at my notes went wrong. So I'm back in mesh terrain, I'm in generate block, and that little bit of code that we wrote, I'm going to replace with, first we just store this string, which will be our key for our terrain dictionary. So then we can just write this.td get, and we're not writing all of that inside there. We could do that, but I just decided to do that in my preparations slightly differently. So I'm then saying if that position is none, so if there isn't anything there, then the terrain dictionary at that position equals a gap. And I can reuse my key. Oh, that's why I'm storing it in that variable there. Okay. I'm kind of hopeful, but a little bit suspicious that this still won't work. It was weird. It was just the way that it kind of spawned things very quickly. Okay. Got to expect it just to pop back. Okay, nothing popped back there. What about here? Okay. None type is not subscribable. So there, I think it's because I wasn't. Anyway, I don't know why. I don't know why that was happening. Let's just carry on. It was something to do with trying to mine when I hadn't highlighted something properly. It wasn't happening in my prepared code, so I've guarded against that somehow. Again, I'll put the solution to that in the comments, or maybe in the comments. I could pin it at the top. Or indeed, if you beat me there, you could put it in the comments. Let's just try, going down. That's nice. So the next thing that oh, no, it spawned. I think that might be to do with generating new terrain. Let's just have a look at the prepared code there. Prepared mining system. No, I want to go down to my mesh terrain. Maybe I changed something in here in generating the terrain. None instead of doesn't equal T for mining. Have I done that as well? In my mesh terrain, let's have a look. Mesh terrain, generate the terrain. There it is. Yes, I made a note to myself because I knew I would forget. So my past self knew that I would do this. So yeah, when we're generating terrain, If it spots a gap, that sounds like the one that we've labelled gap. If it spots that there isn't a T in that position, it will just fill it up with some new terrain, which we don't want, because there might be a gap there, i.e. marked with G. So we want to say if it equals none, so there's no terrain and there's not a gap that we want to kind of protect as empty space where we've done some digging, then we can generate a block. Right. So that should sort out that problem. I did see another little bug. It might be affected in that there was still a gap in the terrain when I was digging down. Let's try and dig in this low place. Just thinking aesthetically, what we want to do is maybe generate soil and things. Because at the moment, we're just using the standard grass block, which has like grass on top of it, which looks a bit silly. What if I do one there? No, that's working. What about one there? Okay, so we might be lucky. What about there? I might be lucky in that the previous bug was causing the other bug. Lovely. Oh no, there's it should have done some wall there. So there's something going on. I'm not sure what's happening there. But anyway, so mining is mostly working with a few bugs. I'll be interested to find out what it is. Okay. If you find a solution to those bugs, again, put them in the comments. That'd be brilliant. But yeah, we've got basic mining working, and now we're a hop, skip, and a jump away from building, because we've done the highlighting stuff. Brilliant. Right. Thank you very much for watching. Merry Christmas, and I'll try and bring out a new video as soon as I can. Thank you very much. Goodbye.